All right, I think I'm live now. So let's go. All right, my name is Daan van der Plas. I am a support engineer at Parity Technologies, and I am going to do a deep dive into Smoldot, which is a substrate Polkadot light client. For the agenda, I am going to do a short introduction to Smoldot, followed by a high-level overview of the main components within the code. Then I'll do a short deep dive within those components. I'll then show you a short Smoldot in action using subxt, and I will then show you the code behind what I just did before that. And yeah, hopefully there are some time for some questions in the end. So I wrote an extensive knowledge base, Smoldot Hello World. This is the link. I wrote it in HackMD. Everything that I'm explaining right now is described there and even more. So I highly recommend to check that out. I also did a presentation at Decoded 2 weeks ago where I gave a high-level explanation of what Smoldot is and what problems it solves and why it is needed, etc. So if you're very new to Smoldot, I recommend to check that out as well and then come back. But yeah, other than that, let's go. So to give a summary of basically what I explained in that Decoded talk, what we want is when we have a blockchain network, we want to be able to talk to any of the nodes within this network. And in addition, we want that the interaction, the data that we receive, that it is in a trustless manner, so that we don't have to trust any of these nodes that we interact with, but that we verify everything ourselves. So there are two solutions to that. One is that we all run a full node, which is basically the validator binary, which is a very resource intensive program because it holds the states of the last 256 blocks. In addition, it verifies all the blocks and all its transactions. And yeah, this requires also a lot of storage. So in order to have this on the back end for an application, for example, you would have to run this 24/7. Otherwise, it's just too slow to boot it up, use it for your application, and shut it down again. So that's why we can't all run a full node. And this is where Smoldot comes into play. And Smoldot only holds the minimal amount of information that it needs in order to verify finality and consensus related information regarding the protocol. And because it has this information, it can verify what the latest finalized block is. So what is the latest true state of the database within the blockchain. And by verifying that, it can start requesting data within this database. And because the nodes that we interact with provide us the Merkle proofs we need, we can also then verify this against the finalized information that we also verified. This, because Smoldot only it's specifically designed to only have this minimal information. It's very light, and it's also very fast. So again, this is all more explained in my talk. So if you don't get this right now, go check that out. But other than, let's continue. So if we go into the code, you can separate, so to speak, the code into 6 main pieces. The chain spec, where it all begins, the networking service, synchronization service, runtime service, the transaction service, and the JSON RPC service. Let's now dive into all of them and what they do, why they are so important. As for the chain spec, when we initialize a client, any node that wants to connect to a blockchain, we give it the chain spec, which contains all the information that the client needs to successfully interact with a blockchain network. So if I go here and I, for example, go to Smoldot demo chain specs, Polkadot, this would be a chain spec of Polkadot. So the name, the ID, boot nodes, which are very important to know. We need some nodes to initially connect with to join the network. And some other properties to the chain. And we have the genesis state, which contains the initial state of the blockchain. And for example, we obtain the runtime from that. And through the runtime, we obtain the initial information regarding grandpa, for example. So who are the first active validators? I forgot to mention that, but that is what is key to the whole fast syncing of Smoldot. Is instead of verifying every block from begin to now, we only verify the changes in the active validator set. And the active validator set are the validators that are chosen by the nominated proof of stake system. And they earned the rights to build new blocks and help vote on blocks to finalize them. So if we know those validators, we can verify their signatures and verify whether a block is finalized or whether this particular validator earned the rights to build this block, this slot. So coming back to the chain spec, it contains a lot of information, the runtime version, the runtime itself. And if we go to the end, we also have the light sync state. This is also known as the checkpoint. So instead of always syncing from the initial state of a blockchain, we can also add the light sync state, which is later in time and provides the information that Smoldot needs to start from that particular moment. So yeah, that's the chain spec. If we then continue, we have the networking service. The networking service, it has three main tasks, which is peer discovery. So very simply put, through the Kademlia protocol, it decides which node, which pair that we are connected to. We send a Kademlia request, and this pair will then send us addresses of pairs that are closest to a certain parameter. And we then obtain those addresses, and then we start connecting with these pairs if we need more connections. Processing connections. So when we initialize a connection with a new pair, we either create a single stream connection or a multi-stream WebRTC connection. Again, just go in the article if you want to learn more about it. It's all there. But a single stream connection, Smoldot will create substreams within the connection itself, and with a multi-stream, with a WebRTC connection, the browser does this for Smoldot. And what is a substream? Let's say you have a connection between two nodes, a connection, one single line, but within that connection, there are multiple substreams which are different streams of information that are being sent between those nodes. So it could be a request response. So I request something and the other node responds, or it can be subscription where this node just pings it like, hey, new block, or new grandpa commit, new grandpa commit. Those are subscriptions. Last, processing networking service, which is kind of the coordinator of the whole networking service, which coordinates if the other services that I will cover hereafter, they want specific information, they send it to the networking service, and the networking service makes sure that it will be sent to the right pair. And also the other way around, when we receive information from these pairs, the networking service makes sure that it will be sent to the right service, the network service. I also created those diagrams in that knowledge base. But yeah, as you can see, all these different connections, all different asynchronous tasks. So this whole code base is full with asynchronous Rust, which took me a while to figure out. But yeah, it's really awesome. But yeah, we get messages, we process these messages. For example, if there's a response or a notification that it belongs to the synchronization service or whatever, we send it to the synchronization service. And when they needs some information, it requests it to the networking service, and it makes sure that it sends it to the right connection. Yeah, you have to go through it a little bit more yourself, but it is there. So now the synchronization service. The synchronization service is different for the relay chain and the parachain, and I will explain that. So if we start with the relay chain, it starts with the warp sync protocol, and this is what I mentioned before. This is where we only verify the changes to the authority set. And these pieces of information, these proofs, are called fragments. So we request fragments. Here we request fragments. It prepares a request. It holds a list of sources about what information each pair it is connected to has. It gets the pair and it makes a request and sends it to the networking service. Then later on, we will retrieve that information and we receive a fragment. We verify the fragments by verifying the actual signatures of these active validators. And yeah, in that way, we progress in the warp sync protocol. Eventually, when we come to the latest era, there's not a new era to jump towards to, so we then change to the all fork sync protocol. And this is very similar to how a normal full node will sync. So we will get or hear gossips about new blocks, but not blocks with block bodies, with transactions in it. We are only interested in the block headers. And yeah, it will hold a list of all these new blocks until they are finalized. So we also hear all the grandpa commits, and Smoldot will verify them. And when a block is finalized, it doesn't have to hold the list of all the other, for the new blocks that follow up. But in this way, it syncs with the network, and by only holding these latest finalized, or the latest finalized block header and the block header of the new blocks. So yeah, a lot going on here as well. So in order to explain you how the parachain syncing service works, I'll first have to explain the runtime service of the relay chain side. And that will become clear later on. So the runtime service, what does it do? Very easy. Well, the sentence is very easy, but it's not that very easy. But it downloads. It will make sure that it will always has the latest finalized runtime. And as you might imagine, this runtime doesn't change that often, especially during a period where Smoldot is connected to a chain. So whether this would happen during a session when you are connected to with Smoldot, I don't know, but it is there. So when it changes, it will know and it will download the new runtime. And this is required for the transaction service, the JSON RPC service of the relay chain side. But also, if we want to connect to a parachain, the parachain synchronization service needs the runtime service of a client connected to the relay chain side. This might be a bit confusing, but I have an image later on that will clarify that. So we get updates from the synchronization service, or the runtime service gets updates from the synchronization service about new, best, and finalized blocks. In the block header, we can find whether there is a runtime upgrade. If so, we start a runtime download by making or requesting a storage proof from our peers. So because we need this new runtime wasn't blob. So we will send it to the synchronization service sends it to the networking service, and then etc., etc., etc. We retrieve the wasn't blob with the Merkle proof to verify it against our finalized header, because in the header is the state root. That is how we can verify all the pieces of data within the database of a blockchain. But we now have the WASM blob verified, finalized, everything. We build the WASM virtual machine, and boom, we notify the transaction service, JSON RPC service, parachain synchronization service, that we again can execute runtime calls. So if we go back now to the parachain synchronization service, we, in order to, or the truth about a parachain state is determined on the relay chain. So parachain nodes can talk to each other and build blocks and make changes to their state. But if they're connected to the relay chain decides whether these changes are actually applied to the state. So the state of the relay chain, Polkadot, has the latest parachain headers of the parachains connected to it. So when we have a finalized block, for example, we then, and we have the finalized runtime, we make a runtime call, which is called the parachain host persisted validation data runtime call. And this will gives us the parachain header of that in the state of that particular block. So when we call that against a finalized block, we have the finalized latest parachain header. So we then compare this, because we're also connected to the parachain in the parachain networking service. So we compare this to our with our nodes, like, hey, do you have this parachain header as well? So in this way, we are synchronizing with the parachain blockchain network. So if we then continue, I hope that made sense. By the way, let me just check those comments if I can. Is there anything I can answer? No. All right. So let me just continue. All right. So the transaction service. The transaction service is responsible for verifying transactions, sending transactions to the network, to the peers that we are connected to, and provide status updates regarding these transactions. And by these transactions, I mean the transactions that the application or the user of Smoldot submits to Smoldot. So we are not interested in other transactions in the network. We are just interested in the transactions that are submitted via the application. We verify, send it to the network if it's valid, and then we will request block bodies from the new blocks that we get thanks to the networking service, and then we check whether our transactions is first added to a block and then later on if this block is finalized. So we can therefore, in a trustless manner, independent, like submit a transaction to Smoldot and verify everything ourselves, which is again really cool. So yeah, the transaction service. When we then continue, so this is have a look yourself. It's or maybe what is cool is like, so how do we verify a transaction? We use the runtime again, so we need the finalized runtime, and we need. Oh, and I forgot to mention that in order to execute a runtime call for Smoldot that has no state. So if we execute a runtime whatever call, and during this execution of this extrinsic, we need to read values in the state. We don't have those. So before we execute a runtime call, we send a call proof request, which then these pairs will provide us the values within the state that we will need during the execution of the runtime call, and again provide it with a Merkle proof so that we can verify whether this is actually the true data. So yeah, cool. Last, the JSON RPC service. So yeah, this is where the application is mostly interacting with, or only maybe, but we send request response. We can send request response RPC calls, which is, hey, give me this piece of data, or we can start subscriptions like, hey, give me updates about the latest finalized blocks. So yeah, another diagram. So a good mental model to have in your head right now, and this took me a while to get clear as well, but if our application connects to Smoldot, or uses Smoldot to connect to Polkadot, to a relay chain or Rococo, whatever, it looks like this. Yeah, so all these services, etc. If we connect to a parachain, it looks like this. Because again, in order for a parachain, in order to verify, to be able to verify a parachain header, it is all determined on the relay chain. So we need to synchronize with the relay chain. We need to be able to sync with them. We need the runtime of the relay chain. This is also why a collator has a Polkadot validator client and a Polkadot node and a collator node within the entire code thingy. So yeah, that is important to take away. So, and in order to synchronize with, we need the runtime service of the relay chain. All right, so I want to do a quick demo, but before, let me check if there are any questions. No, cool. All right, Smoldot in action. So I have this here. SubXT. SubXT is a tool you can use to easily submit transactions to a substrate node, and they very recently added Smoldot to it, so you can do all of that stuff with Smoldot instead of doing all these calls to a RPC node. SubXT, yes. So yeah, very basic. I will later on explain you how to initialize a Smoldot, but we initialize Smoldot here, the address, and we just make a simple balance transfer of 1 with 12 decimals on Rococo. And yeah, let me show you this. So I'm gonna transfer from test 1 to test 2. So we now have 96.9997 and 103. And I am now going to run that particular executable or main program thingy example, and we will initialize Smoldot. We will start connecting to the boot nodes. We will read the change spec, and we will start with the Grandpa warp sync protocol, as you can see here. And this takes a while because probably we are, maybe, I'm not sure, but in the Rococo change spec, maybe there's no checkpoint. So this light sync state. So we might start all the way from the beginning. And you can see Grandpa warp sync finished, finalized, block runtime ready. So we can validate it. The transaction is valid. And we are now checking the block if it's being added and finalized, which it is not yet. Kaboom! Balance transfer success. And if we now check Hatzeflats 95.997 and 104, so we now did a complete transaction through Smoldot in a complete trustless manner, and also very decentralized because we're not connecting to a RPC node. No, we are joining the network as a client. And yeah, this is the future, ladies and gentlemen. So yeah, this was a short demo I wanted to show. And what I want to do now is basically show you what is happening under the hood. So right here, let me take any questions. Can we find this example somewhere? Yeah, so this example is if you go to subxt and you go to subxt examples, and then you have unstable light client transaction basic. I think here they connect to Polkadot and they do a transfer between Alice and Bob. But yeah, you can modify that. Cool. Code walkthrough. So this is in the Smoldot repo, and it is in the Lightbase examples basic, where it simply connects to Polkadot and makes a request to subscribe to new block headers. So how do you initialize and connect or initialize a Smoldot? You basically create a new client and you add a chain where you provide the chain spec. So here I provide the Polkadot chain spec. I enable JSON RPC requests. You can set some parameters. I think it's advised to just take those. And if you want to then connect to a parachain, you take this chain ID that is given to Polkadot by Smoldot, and you take that chain ID and you use that later on here to connect to a parachain, where here we are connecting to Akala, but we have to provide the chain ID that Smoldot knows for, or that Smoldot has given to the whole connection, the whole client side of connecting to Polkadot. And this is how you can connect to a parachain. So now we are going to see, so now let's assume we do a author and submit watch extrinsic, which is, I think, the name for when you want to submit a transaction. So what we're now going to do is what I just did on Rococo. I'm now going to show it, so to speak, in the code. So we go to the JSON RPC request. So the cool thing about this Smoldot repo, I learned a shit ton of it, is because the whole repo is not so hard to just go through and follow the trail of the code, which is sometimes hard in Substrate by all these, there's all these traits and stuff. In addition, which you will see during this code walkthrough, everything is documented by the developer of Smoldot, Pierre Krieger. Shout out to him. But yeah, you can. It's like a book. You start, and you just follow the trail and see how everything works. I literally learned about networking and all these single stream, multiplex, whatever. It's hard, and if you have the time, but you will learn so much. You will learn about the protocol. You learn about how these verification, everything works. I highly, highly recommend it. But yeah, let's just continue. So we follow the trail. We queue this RPC request because, of course, you could request a lot of JSON RPC requests to Smoldot. We try to send it, and then we push it to this queue. And then we can see, I think here it pops. Yeah, so here it gets these requests. Notify. Okay. Okay, so, what happened? A new request. When ready to send. So what happened? What happened? No, we have a what happened new request. Here. New request. So we basically put this variable in this new request. And then we parse it. Parsed request. And okay, so we give the request ID and the method. Yeah, so we have the request ID and and here we match the parsed request. So what we're now looking for is we're looking for author submit, but I think we need author watch. Author submit and watch extrinsic right here, which leads us to starting a new subscription. So you can see return event handle subscription. So if we then go back to the function and we look for where this function is called, we are not interested in the full node, but in the light base. We can see here handle subscription start, and we are interested in none of those methods. So it is going to send to this channel. So this took me a while as well. These TX, it's often called, is often linked here to a RX, which is a channel between two asynchronous tasks within Smoldot. Like I said, there are many, but we now basically just look for RX here, and we receive it on this end, and it is a subscription start or a subscription. So we now start or handle subscription start pulls one request from the inner state machine and processes it. Print a warning for legacy JSON RPC functions. So we now want, again, author, submit, watch extrinsic. Boom. Request. How did this author? Here. Each call is handled in a separate way. So that was above was for logging, I think. So here, submit, author, submit, and watch extrinsic. Submit and watch extrinsic handles a call to. I'm not sure whether author, submit, and watch transaction unstable. I'm just going to do this one. To be honest, I don't know what the difference is. Oh, no, I should go to... Oh, no, sorry. It's just a... So, it gives transaction false or transaction true to transaction or is legacy. And then we will give this subscription an ID. And then we will... okay, so the subscription is started. It's probably sent somewhere. Submit and watch transaction here. So we send it to the background. And to the background is probably the transaction service. I'm going to open... No, I'm not. I'm going to do it like this. So I am now going back all the way where we started. So we added a chain here. Yeah. And instead of going here to the JSON RPC request, we go and add a chain to Smoldot. And this is a very big function with a lot of stuff. So here's all the chain spec stuff. It downloads the runtime and a lot. But for now, I'm going to skip that, and we're going to start services. And this is where all the cool stuff is happening. Whereas, for example, initializing the networking service. So everything is set up there. And the whole synchronization service, the runtime service, this differs if it's a relay chain or a parachain. Again, you can see everything is documented, and it's like a book about Polkadot and blockchain. Super cool. But we are interested in the transaction service. And if we go take a look, we can see two background from foreground. And this two background on the left is this two background. So this is given to the background, or no, from foreground probably. Oh no, to background, yeah. And then it will end up here in the from foreground. So, and then we start it here. Here you can see it spawns a task for the transaction service. And then this is again a huge function, so I'm gonna hop around a little bit, a lot, I mean. But first, we subscribe to the runtime service. So we want to know, hey, do we have the finalized runtime, etc. I'm going to, oh, damn, I can't do that. How do I do that? I don't know. I wanted to move it a little bit to the left, but... so yeah, on the left, we send it, and then we can probably... If we look for from foreground, you can see we get a message, and you can see to background submit transaction. So handle the situation where the same transaction has already been submitted. Well, that's not the case. Add unvalidated. So we add it to pending transactions. So if we go back, we can then see or find this pending transactions, and we are looking for the unvalidated transactions here. So we have these pending transactions that have just been added to. We get the transactions that have a status of being not validated yet, and we will start a validation process. Boom, validate transaction. So let me just quickly. What is the difference, if any, between Smoldot and Lightbase? Lightbase is Smoldot's implementation, basically. So a platform agnostic loss right that can connect to the base for the Smoldot one. Yes, exactly. Yes. Thank you, evil robot. So validate transaction. So what we will do is we have the runtime, and we will start the whole validation process, where we first send a call proof request to the synchronization service. So we need the values within the state to be able to execute the validate transaction runtime function. So we're doing that. And so we send it to the synchronization service, which will then send it to the networking service, and then the networking service will receive it from a connection, and then send it back to the synchronization service, and the synchronization service will send it back here too, and ends up in the call proof. What we then do is we decode this information and we verify the proof. I'm not going into this because that's a lot, but definitely check it out if you're going through the code yourself. And so the call proof, if that just goes right, we just have a valid call proof, and we are going to get the virtual machine that we downloaded, that we built from the wasm blob, and we will now validate the transaction. Here, no, that's not. So yeah, we have the runtime call, and we have the runtime because the call proof was valid, etc. And now we're going to validate the transaction. So we get the runtime version. So there are two versions, which I'm not sure what the difference is as well, but I'm just taking this one. So we will now run the virtual machine with the runtime that we got. This is, as you can see, tagged transaction queue validate transaction, and skill encoded transaction, etc. The header, and so these values that we obtained, these from the call proof, we don't send that directly with the execution. So what happens is we run it, and if we that's not important. Well, here we run it, and what can happen during an execution of the runtime is that we request to execute this runtime API or this API call, this function, and it can stop due to an error, or it can stop because it needs one of these values from the database, which we have and also verified. So the execution of that runtime call will pause, request that value, and then we resume the execution of the runtime with that value again. And this can go on, either stops through an error, and then we say like, yeah, didn't work, or everything is correct and the transaction is valid, which we then go back, validation in progress, and we can see here it's finished, or we need a storage get, or all these other stuff. So yeah, it breaks if it's successful. So we get out of this loop, and we're all the way back here. So we now validate a transaction. We now want to, we need to broadcast it. So it broke, then it will go out of this validate transaction. Yeah. So block hash result. Yes, we have the result. Validation future remote handle. The future that will yield the validation result is stored. Yes. Validations in progress, pending transactions. I think validations in progress. Let's see. Yes, so here, unvalidated transaction, no. Validations in progress. Yeah, we break from here. No, pending transaction. No, we did all of that. Yes, remove transactions that have been determined to be invalid. Yeah. Start block bodies downloads. Not really, because we first need to send it. Push. Start block body down here. So probably somewhere here. Pending transaction, missing block bodies. Yes. Actual download start. Okay, so I can't really find the point where we send it to the network. Maybe we will find it later on. But what happens here? We send it to the network, and we will now have this transaction that we validated, and it has the status of broadcasted. Maybe I can search for that. No. So we will now start requesting block body requests regarding the new blocks that we are hearing from the gossip. So because we want to know if our transaction is added. So we will now start or request the synchronization service again. Hey, can we have a block request regarding a certain block number and block hash, as you can see here? And we are then downloading it. We will also verify that because we have the extrinsics root in the block header. So we can then verify whether that's, we can verify the whole, all the transactions of that particular block. So this is the point where when we get updates regarding finality, we will then update the status of our transactions. Hey, drop reason, it's finalized, and that will then come back to the JSON RPC service, and that will then send it to the application. And that comes from here. So here we can have notifications from the runtime service regarding new blocks, and it will then so new blocks, new notifications regarding finality, best blocks as well. Yeah, it's a huge thing. Block downloads. I want to find the networking service. Uh, Next re-announce. Yes. A transaction. Yes, this is it. So maybe re-announce transaction. Continue if transaction doesn't exist. Is included. Don't gossip the transaction if it hasn't been validated or is already. So it is included. Yes. So we continue, and then transaction. Yes, yes, yes. Only announce. Yes. Next re-announce. Push. Blah 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 blah. Announce transaction. Hatzeflats. No definition found. What is that? Okay. Really? Okay, but yeah, that would then go to the networking service. I don't know, my Rust analyzer stops working, but and then it will send it to the peers that we're connected to, and then we continue where we were before, and it's added here. We can see transaction status broadcast, so it's broadcasted. Oh, my Rust analyzer, man. Wait, now? No. And then we also have the transaction status of added to a block. What I with this code walkthrough, I wanted to show you a little bit, well, the code, of course, but mainly just for me, it was so cool to see the actual, you know, that these blocks are being sent, transactions are being verified, runtime is being downloaded, executed, etc. Everything is in here, everything is documented. Um, Man, I spent 2 months, maybe it was a bit too much, but I learned so much. So I highly recommend it. And as you can see, there's so many to dos, and it's only Pierre who's working on it. He's an absolute genius. But if you have the time, if you have the expertise, yeah, see if there's maybe an issue you could tackle, um, or fork it and I don't know, implement it a little bit differently. There's much to do. But other than that, yeah, this is how you submit a transaction. It's finalized or it's verified. It's sent to the network. We're looking for updates regarding the blocks, whether the block is finalized. And yeah, we can do this with, this is how everything is basically done. If you do it through Smoldot, everything is trustless, which is super cool, which is the future. So yeah, that was the code walkthrough. Cool. So thank you for listening. If there are any questions, short, small repo right here. Check it out. It's amazing. Substrate Connect repo, which has a small dot for which uses small dot in your web browser. Trappist Extra, where we integrated Smoldot into Flutter, so you can use and build applications using Smoldot, and learn and stay updated. Check out this knowledge base I wrote. It's very elaborately. Check my Dakota talk. Never mind. And there's also a Substrate Connect workshop, which is done by Nikos, and then you can learn how to, use Substrate Connect. But other than that, thank you very much. Are there any questions? Please do. Would it make sense to add some sort of ZK tag to make Smoldot more efficient or more light? Well, I don't see, like, I think you can. So if this is in what is it included in Substrate, I think Smoldot will be able to do that as well, verifying zero knowledge proofs. So yeah, I don't see a reason why not. Would it, but so this would be then, yeah, what I said. But then you would need, well, it really depends on the protocol. So Smoldot is really designed to make all these verifications thanks to the whole Grandpa protocol with these justifications and the active validator set. So if your relay chain would now, I don't know, use zero knowledge, the whole Smoldot implementation, The protocol implementation is different. So, but yeah, like Smoldot understands substrate. So it would need some tweaks though, but it would definitely be possible. Um, yeah. So no other questions. Thank you. But yeah, last, like, this is the future. So learn it, and especially as an application developer or someone with an idea, like start with Smoldot. Everyone should use it. It's how Web3 is envisioned, and right now many people are making excuses. No, I don't want to be bold, but we should start. It should be the norm. Back to the future, back to Smoldot. Hell yeah. Um, okay, I think we're done. Thank you all for coming, listening, and I hope you learned a lot. I didn't included my element here, but yeah, send me a message on Twitter otherwise. Ciao, Laios. All right.